Hello everybody. So now we'll be going through the concept of composition of non-concurrent flow system. In the previous session, we went through the concept of moments, which is required to compose, or which is one of the essential factors to find the resultant of non-concurrent flow system. So let us go through the composition of non-concurrent flow system. Before we go through the composition of non-concurrent flow system, let us try to understand the difference between concurrent flow system and non-concurrent flow system. So concurrent flow system is a system where all the forces have a common point, or one point is common for all the forces. One point is common for all the forces. If I consider four forces, this particular point, let me name this as O. Point O is common for all the four forces here in a concurrent force system. So now, in a composition of concurrent force system, so when we find the resultant of this concurrent force system, even the resultant will have that particular point as common. So it's very easy to locate the resultant because even the resultant should have the same point as common point in a concurrent force system. Whereas in a non-concurrent force system, all the forces will be scattered. They do not have common point. So if I find the resultant of these four forces, resultant may lie somewhere here. It is very difficult to locate the resultant. Hope you are in a position to compare. So here it is easy to locate the resultant because it has common point, and even the resultant should have the same point as a common one. But here, since all the forces are scattered and they do not have common point, even the resultant will be somewhere. And you have an extra task here in the composition of non-concurrent forces. Once you find the magnitude of resultant, you have to locate this as well. You have to locate the result. You have to find the exact location of the resultant. Finding the exact location in the sense will be given with a reference point, or let me write it as a reference point itself. Will be given with a reference point in the problem. A reference point will be given, and with reference to that particular point, you are supposed to locate the resultant. Locating in the sense you have to find the distance, x-intercept and y-intercept. Distance, d, x-intercept and y-intercept from the reference point. Reference point will be given to you, and from the reference point you are supposed to find d, x-intercept and y-intercept. That is, you are locating the resultant. You'll be finding the magnitude of resultant, and once you find the magnitude of resultant, you have to locate the same. And this is how you locate. You'll find the distance, that is perpendicular distance from the reference point, x-intercept from the reference point, and y-intercept from the reference point. If you do this much, it's as good as locating the result. This is in the case of non-concurrent force system, or this task is extra. Finding d, x-intercept and y-intercept. Hope this is clear. Hope you're clear with the difference. In a concurrent force system, even the resultant originates from the same point, but whereas in a non-concurrent force system, resultant will be somewhere because all the forces will be scattered. Since resultant will be somewhere, you have to locate the resultant. To locate the resultant, you'll be given with a reference point, and you're supposed to find the distance from reference point, x-intercept from reference point, and y-intercept from reference point to locate the resultant. Now, let us go through the steps to find the resultant of a non-concurrent force system. Steps to find the resultant, or find and locate the resultant. You have 5 steps here total. So step number one is to resolve all the inclined forces. You have to resolve all the inclined forces. If you have any inclined force in the given system, you're supposed to resolve it. Step number two. So once you resolve all the forces, in step number 2, you have to find the summation of all the forces moving along the x direction. In step number 3, you'll be finding summation of all the forces moving along y direction. In step number 4, you'll be finding the magnitude of resultant. R is equal to square root summation of fx squared plus summation of fy squared. Fx squared plus summation of fy squared. Now, so these are the 4 steps, and you're familiar with these 4 steps because these were the steps in concurrent flow system as well. So now you got the magnitude of resultant. Magnitude of resultant. Now we have to locate the resultant. Locating the resultant will be done in step number 5. Step number 5. So step number 5. In step number 5, you will find the moment. You'll find the moment produced by all the forces. You'll find the moment produced by all the forces about the reference point. He'll be given with the reference point. You'll know the reference point already. Reference point will be given. Reference point will be given in the question. So in step number 5, what will you do? You will find the moment about the reference point. Moment about the. Hope you know how to find moment. We went through this concept in the last session. So we will be finding moment about the reference point. And once you find the moment about the reference point, you'll find the values of x-intercept, y-intercept, and d. So d is the absolute value of moment about reference point by r. R is the result. X-intercept is the absolute value of moment about reference point by summation of fy. Summation of fy. Whereas y-intercept is the absolute value of moment about reference point by summation of fx. Summation of fx. This is how it goes. This is the method. So step number 5 is extra here. Till step number 4 you are comfortable. Step number 5 is extra. You have to keep one thing in mind. Is that till step number 4, you will be considering both magnitude and direction of force. Both magnitude and direction of force. Whereas in step number 5, when you come to step number 5 deals exclusively with moments. So when you come to step number 5, you will ignore the direction and consider only the magnitude. No direction in step number 5. Direction is being ignored. Got it. So you have to be careful here. So till step number 4, you'll be considering both magnitude and direction because you'll be dealing only with forces till step number 4. So when you come to step number 5 exclusively deals with moments. So since it exclusively deals with the moments, you are supposed to consider only the magnitude of force, ignore the direction of force, and consider the direction of moment. If it is clockwise, consider the entire moment as positive. If it is anti-clockwise, consider the entire moment as negative. Or step number 5 is completely concerned with moments. Till step number 4, you will be dealing with forces. Hope all the steps are clear. Hope all the steps are okay and clear. So let us start solving the numericals on this. I'll solve some extra example problems, and the rest of the problems are to be solved by going through the notes. So let me open the notes. Let me start solving the problem. Let me solve the first problem in the notes. Problem number 1. You have a pole in this ring, and this is the ground. You have a force of 60 kilonewton here. 60 kilonewton. And you have another inclined force of 40 kilonewton magnitude. 40 kilonewton magnitude. And you have one more thing, which is an external moment. I'll let you know what this is. Of 20 kilonewton meter. Of 20 kilonewton meter. And this angle is 30 degrees. This distance is 3 meters. And the total distance on top 5 meters. This is the given question. And The reference point is given as O. This is the reference point. This is the reference point. So you are supposed to, as per the question, you are supposed to find the resultant of these two forces. Resultant of these two forces, both are non-concurrent. Resultant of these two forces with respect to the point O, or with reference to the point O. With reference to point O. Hope I'm clear. You're supposed to find the resultant of these two forces with reference to the point O. With reference to the point O. So O is the reference point here. O is the reference. So what is the step? What is the first step? Step number one is to resolve the inclined forces. How many inclined forces do we have? We just have one inclined force here of 40 kilonewton magnitude. Resolve this force into its horizontal and vertical components. So this is the horizontal. Make sure that you draw the resultant components exactly at the point of application, and this will be the vertical component. So horizontal component will be 40 cos 30. I'll do one thing. Since till step number 4 you'll be considering the direction, and in step number 5 you'll not be considering the direction. I'll write the direction in bracket as minus because it moves horizontal to the left. You'll be using the sign convention which is being written inside the bracket only till step number 4. Only till step number 4, not in step number 5. In step number 5, ignore the sign convention which is being written here inside the bracket. So horizontal component is this, and even vertical component, right? Minus inside the bracket. 40 sine 30. These are the two resolved forces. So step number 1 is done. We're done with step number 1. What is step number 2? Step number 2 is to find summation of all the forces moving along the x direction. Summation of all the forces moving along x direction. We have minus 40 cos 30. You consider the direction plus 60. This is summation of fx. And step number 3 is to find summation of fy, which is minus 40 sine. Only 1/4 you have. And step number 4 is to find the resultant r is equal to square root summation of fx squared plus summation of fy squared. Find the magnitude of r, substitute these two to get the value of r. We'll get the value of r. And till step number 4, it's quite simple. It's quite simple. You can find easily. You're comfortable with this as well. You know how to find. So r will be around 320 kilonewton. Magnitude of resultant, you have to calculate this. Try doing this, you'll get the answer as 320 kilonewton. Now, step number 5. Going to step number 5. Step number 5 is to locate the resultant with respect to the reference point. Locate the resultant with respect to the reference point. So, in step number 5, you have to find, initially you have to find the moment about the reference point. The moment about the reference point. Reference point is O. Moment about the reference point, and reference point is O. We do this exercise just to locate the resultant. Locating in the sense you'll be finding the x-intercept and the y-intercept. So to do that, you need moment about the reference point. Moment produced by these all of these forces about the reference point. About the reference point. Now, how to calculate moment is the question. You know how to calculate, is it not? Let us consider all the forces one by one. So in the case of moments, you'll be ignoring the direction. Let me consider this force of magnitude 40 cos 30. 40 cos 30. Line of action is horizontal. Line of action is horizontal. Force moves horizontal to the left, and the point about which we need moment lies below the line of action. So this should produce moment in this direction. It is anti-clockwise. Minus, what's the magnitude? 40 cos 30. Consider only the magnitude 40 cos 30 into the perpendicular distance is from line of action to point O. It is 5. It is 5. Now you have 40 sine 30. With this force will not produce any moment about O. Why? Because when you draw the line of action passes through. Line of action passes through the point O. So this force will not produce any moment about point O. Now let us check whether this force of 60 kilonewton magnitude produces clockwise or anti-clockwise moment about O. So let me draw the line of action. This is the line of action. Line of action is horizontal. Force moves horizontal to the left, and point about which we need moment lies below the line of action. Lies below the line of action. So this force should produce moment in this direction, which is clockwise, plus 60 into, what's the perpendicular distance from this point to O? It is 3. It is 3. So you will get the value of moment as, and also, okay, I forgot one more thing. You have an external moment here. You have an external moment. This is the external moment. This 20 kilonewton meter is the external moment. If you have an external moment given in the problem, include it in step number 5. This you have to remember. If you have an external moment straight away given, it's of force. A moment is straight away given. This particular moment acts on the entire body. So if you have an external moment given in the problem, include it in step number 5. Include it in step number 5. So when you include this in step number 5, this is in anti-clockwise direction, so it is again minus 20. It is minus 20. So find the moment, you will get a value in terms of kilonewton meter here. In terms of kilonewton meter, you get a value, which is moment about reference point, once you calculate. So once you get this, once you get the value of moment about reference point, it's very easy to find the x-intercept and y-intercept. It's direct substitution. It's direct substitution. D is the absolute value of moment about reference point, which is O here in this case, divided by R. Substitute. You know the value of this and you know the value of R. Once you substitute, you'll get the value of D in meters. Because moment about reference point is in kilonewton meter and R is in kilonewton. Kilonewton and kilonewton gets cancelled, you'll get it in meters. So distance. And x-intercept. X-intercept is the absolute value of moment about reference point is O and divided by summation of F by summation of F by direct substitution this is. And y-intercept is the absolute value of moment about reference point divided by summation of F1. You know all of these values. Just substitute it in these formulae and get the value of the x-intercept and y-intercept. Hope the problem is clear. Hope the steps are clear to solve the numerical. So if you have an external moment, you're supposed to remember this. If you have an external moment given in the problem, consider it in step number 5. Consider it in step number 5. Done. So this particular step number 5, where you find the moment about reference point and where you find the x-intercept and y-intercept are extra. These two steps which comes under step number 5 are extra in the non-concurrent force system. When you compare the steps of non-concurrent force system with the concurrent force system. In concurrent force system, you will not be locating the resultant, but here in non-concurrent force system, you will be locating the resultant. As simple as that. So let me solve some more problems in the next video session. Thank you.